Have you ever wondered why NASA is so determined to return to the moon after more than 50 years away? Most people believe it is about history, pride, or unfinished dreams from the Apollo era. But the real reason is hidden in places where sunlight has never touched the lunar surface. Near the poles of the moon there are craters so deep and so cold that darkness has ruled there for billions of years. Inside these silent abysses, scientists discovered something that completely changes the future of space exploration. They discovered water frozen as ice, preserved in perfect conditions since the early days of the solar system. This discovery quietly transformed the moon from a dead rock into the most valuable location beyond Earth. Because this ice is not just water waiting to melt. It is the key to breathing, surviving, and traveling deeper into space. For decades, the moon was seen as a symbolic destination with little practical value. Astronauts went there, planted flags, collected rocks, and returned home. After Apollo, the interest faded because there seemed to be nothing useful left to justify the cost. That perception changed when orbiters began mapping the lunar poles with advanced instruments. These spacecraft detected unusual signals coming from the darkest craters. The data suggested the presence of hydrogen locked inside the soil. Hydrogen is a strong indicator that water may be present. Further analysis confirmed what many scientists had hoped, but never proven. There was ice hidden in permanent shadow. Temperatures in these craters dropped below -200 degrees Celsius. In such extreme cold, any water that arrived there billions of years ago would remain frozen forever. This water likely came from comets and asteroids that struck the moon in ancient times. Instead of evaporating into space, the water became trapped in darkness. Protected from sunlight, it survived untouched for ages. Suddenly, the moon was no longer useless for long-term missions. Water means life support. Water can be split into oxygen for breathing. Water can be split into hydrogen for fuel. This means rockets could be refueled on the moon instead of launching everything from Earth. Launching from Earth is incredibly expensive because of gravity. Every kilogram sent into space requires enormous energy and fuel. But the moon has only 1/6 of Earth's gravity. Taking off from there requires far less effort. This turns the moon into a natural space station, a place where spacecraft can refuel before heading to Mars, a place where astronauts can live for extended periods, a place where humanity can prepare for deep space travel. This is the true foundation of the Artemis program. NASA is not returning to repeat history. NASA is returning because the moon has become essential for the future. The Artemis missions are designed to land near the lunar South Pole. This is where the largest concentrations of ice are believed to exist. Astronauts will explore these craters with new technologies and robotic assistance. They will test systems that can extract water directly from the soil. They will learn how to survive using local resources instead of supplies from Earth. This concept is called in situ resource utilization. It represents a turning point in how humans explore space. Instead of carrying everything with them, astronauts will live off the land, just as early explorers once did on Earth. The moon becomes a training ground for survival on other worlds. If humans can learn to live using lunar ice, they can learn to live on Mars. Mars also has frozen water beneath its surface. The techniques developed on the moon will be essential for future colonies. This is why scientists say the moon is the gateway to Mars. Without the moon, reaching Mars sustainably would be far more difficult. The discovery of ice changed strategic plans for every major space agency. Other nations are also planning missions to the lunar poles, because whoever masters the use of lunar resources will shape the future of space travel. The race to the moon is no longer about flags and footprints. It is about infrastructure and survival. Permanent bases are now part of serious planning. Habitats may be built near the edges of these dark craters. Solar panels placed on nearby peaks of eternal light could provide constant energy. Robotic machines could mine ice continuously in the shadows. Pipelines could transport water to living quarters. Oxygen production units could operate around the clock. Fuel depots could store hydrogen for departing spacecraft. All of this begins with a simple discovery hidden in darkness: water that waited billions of years to be found. This also changes how we see the moon scientifically. It is no longer just a record of the past. It becomes a partner in humanity's future. The silence of those craters now carries enormous importance. They hold the resources that make deep space travel realistic instead of theoretical. For the first time, humans can imagine a supply chain beyond Earth, a network that starts on the moon and extends toward Mars and beyond. This is why NASA rarely describes the return as sim. Behind the public speeches, there is a practical reason driving every mission. Survival far from Earth requires local resources, and the Moon offers exactly what is needed. When Artemis astronauts step onto the lunar surface, they will not just explore, they will inspect the most valuable resource site in human history. They will stand near ice that can become air, water, and fuel. They will begin testing the systems that transform science fiction into reality. The Moon will no longer be a distant object in the night sky. It will become the first true outpost of humanity in space. Scientists now study detailed maps of the lunar poles with intense focus. These maps reveal regions where sunlight never rises above the horizon. They also show nearby ridges that receive almost constant illumination. This unique geography allows energy production and resource extraction to exist side by side. Engineers call these areas peaks of eternal light. They may become the safest locations to build early lunar habitats. From these illuminated ridges, astronauts could access shadowed craters only a short distance away. Rovers designed to withstand extreme cold will descend into darkness to harvest ice. Special drills and heaters will separate frozen water from lunar soil. The collected water will then be purified and stored for multiple uses. Some of it will be reserved for drinking and life support systems. Some will be processed into breathable oxygen for crews living on the Moon. Another portion will be converted into hydrogen and oxygen propellant. This propellant could power spacecraft, leaving the Moon toward distant destinations. The idea of refueling in space changes the economics of exploration completely. Missions that once required enormous rockets from Earth become far more efficient. Instead of carrying all fuel from home, spacecraft can top up their tanks on the Moon. This reduces cost and increases the range of human missions. It also allows larger payloads of scientific equipment to travel deeper into space. The Moon becomes both a laboratory and a launch platform. Every system tested there prepares humanity for harsher environments elsewhere. Living on the Moon will teach astronauts how to manage isolation and limited resources. They will learn to recycle air and water with extreme efficiency. They will practice maintaining equipment far from Earth without immediate assistance. These lessons are essential before attempting permanent settlements on Mars. Mars is months away from Earth, while the Moon is only days away. Mistakes made on the Moon can be corrected more easily. This makes it the ideal testing ground for long-term survival technologies. Scientists also believe lunar ice holds clues about the history of the solar system. The water trapped there may contain ancient chemical signatures from comets. Studying it could reveal how water was delivered to Earth billions of years ago. This means the Moon is not only important for the future, but also for understanding the past. Every sample extracted from those craters is a time capsule from the early solar system. This combination of science and strategy makes the lunar poles uniquely valuable. That is why Artemis missions focus intensely on this specific region. The goal is not just to visit, but to stay and operate continuously. In the coming years, robotic missions will scout the terrain in great detail. They will identify the safest routes and richest deposits of ice. When astronauts arrive, they will already know where to begin their work. Step by step, a permanent human presence will start to take shape. Structures may be partially buried under lunar soil for radiation protection. Inflatable habitats may expand into comfortable living spaces for crews. Communication systems will keep constant contact with Earth. Power systems will run day and night from sunlight gathered on high ridges. All of this infrastructure depends on one simple resource hidden in darkness: water that turns the Moon into a place where humans can truly live. This is the reason space agencies speak about sustainability instead of short missions. The objective is no longer a quick visit and return home. The objective is to build capability that lasts for decades. Future generations of astronauts may see the Moon as a normal workplace, a stepping stone that makes the rest of the solar system more accessible. And it all begins with understanding why ice in shadowed craters matters so much. Because without water, no long-term presence is possible anywhere in space. With water, the impossible slowly becomes achievable. This silent discovery is what changed the direction of human exploration. The Moon is no longer just a distant light in our night sky. It is becoming the first true outpost of humanity beyond Earth. And everything starts with something hidden for billions of years in complete darkness. Water that can become air, fuel, survival, and the gateway to Mars. That is the real reason humans are returning to the moon. If you want to follow humanity's journey beyond Earth and understand the future of space exploration, subscribe to the channel and join us for the next discoveries. And tell us in the comments what you think humanity will find next as we return to the lunar surface.